So this last set of examples has to do with solving exponential equations. An exponential equation is just an equation where your unknown is an exponent or part of an exponent. And as you would expect, they require very different techniques than solving linear equations or quadratic equations or polynomial equations. For a lot of these cases, we will need logarithms, but for a few of these examples, like the ones we have here, you can use other methods. The key here is just to remember that exponential functions are one-to-one. In particular, if you ever have a to the x equals a to the y, then this means that x has to be equal to y. So if you can write both sides as a power using the same base, then you can just set the exponents equal to each other. So for example, we know that 25 is 5 squared. So 5 to the x is 5 squared. So this means that x has to be 2. 36, we can write this as 1 over 6 squared, which is the same thing as 6 to the minus 2. So 6 to the x equals 6 to the minus 2. There we go. And so x has to be minus 2. 4 to the minus x equals 64. Is 64 a power of 4? Well, if you think about it, or if you take out your calculator, you can see that 4 times 4 is 16. 16 times 4 is 64. So this is actually 4 cubed. So we get minus x equals 3. So x is going to be minus 3. 7 to the 3x plus 2 equals 1/7. This is the same thing as 7 to the minus 1. So 3x plus 2 is equal to minus 1. Subtract 2 from both sides and divide by 3, and you get x has to be negative 1. Okay. 2 to the x squared equals 4. Well, 4 I think we all know is 2 squared, so x squared equals 2. And here we get two solutions, right? X could be square root 2 or minus square root 2. Okay. So there we are. Yes, we can have square roots as solutions. Here, hopefully you can see on number 6, we can clearly see the bases are the same. So we can just drop the 3's and we get 4x plus 7 equals minus 6. And subtract 4x from both sides. 7 is minus 10x, so x will be negative 7/10. Seven. I'll let you, maybe you can pause the video if you want. 9 is 3 squared. Okay, but we're still raising that to the x power. Okay. I think we can use properties of exponents, and this will be 3 to the 2x. So 4x plus 7 equals 2x. And so you can see that subtract 4x from both sides, you get x is going to be negative 7/2. Something similar happens with 8. Don't be scared of the e. The good news is there's an e on each side. That's our base, so we can just drop the bases and we get minus x plus 3 equals 2x plus 7. Add x to both sides. Subtract 7 from both sides. Get negative 4 equals 3x. So x is negative 4/3. I hope. Okay. And then just to show, you should be able to do a problem like this. This will come in your homework. And here it says, if 4 to the x equals 7, what is 4 to the minus 2x? You don't necessarily have to know what x is to know what 4 to the minus x is. Or 4 to the minus 2x, because we can see that we know that minus 2x, 4 to the minus 2x, this is the same thing as 4 to the x raised to the minus 2, right? Because this is negative 2 times x, okay? 4 to the x is 7, so this is going to be equal to 7 to the minus 2, which is 1 over 7 squared, which is 1 over 49. Now we're actually going to find out what we'll be able to solve x just directly. But because 7 is really not a power of 4, if you think about the powers of 4, it's 4 to the first, 4 squared, 4 cubed. 7 is not one of those. But there is some real number that satisfies this, and that involves a log. That is where we need logarithms, and that's what we'll be doing in the next section. So we'll leave you in suspense here, and as long as you make sure you understand all the other examples on this page, you should be okay for the homework in this section.